Hey everyone, we're getting started here on your Chapter 11 practice test once again. We're going to continue from question 6, which is to find the area inside one leaf of the four leaved rows r equals 7 sine of 2 theta. Now, we probably don't have to do a whole lot here in terms of graphing. In fact, if you follow those simple rules that we talked about in class, you don't even have to really graph this. So we know this is a sine rows. So with the sine rows, we want to find, or we want to solve r equals 0 for the first two values of theta, first two positive values of theta, really. So let's go ahead and set our radius equal to 0. And 7 sine of 2 theta equals 0. Well, that's going to be 0 when sine of 2 theta equals 0. In turn, sine of 2 theta is going to be equal to 0 when the angle 2 theta equals 0 in pi. Now this first solution, 2 theta equals 0, that solves out to theta equals 0, which I forgot, that's always going to be the case. So the lower angle here is always going to be 0. But the upper angle here, 2 theta equals pi, well, that's going to happen when theta equals pi over 2. So we've done it. We have our two angles for the first leaf of the four-leaved rows. This technique is always going to give you the lower and upper bounds for the first leaf of a sine rows. Now the area for any polar curve is the integral from theta 1 to theta 2. 1/2 r squared d theta. Let's do some substitution. Theta 1 equals 0. Theta 2 is going to be pi halves. And then the radius is going to be 7 sine of 2 theta. This gives us our full integral that we're going to have to evaluate to find the area inside one leaf of that four-leaved rows. Now we're going to go through the process of simplifying this. The first thing to do is to square everything inside the parenthesis. 7 squared becomes 49. Half of 49 becomes 49 over 2. The square of sine of 2 theta, we'll rewrite that as sine squared 2 theta. To simplify the sine squared 2 theta, we have the handy power reduction formula, where sine squared of any angle u is 1/2 of 1 minus the cosine of double that angle. It so happens that our angle is actually 2 theta. So we get that sine squared of 2 theta is 1/2 of 1 minus cosine 4 theta, which we'll substitute. Now we have a 49 over 2 multiplied by 1/2, which we can simplify as 49 over 4, which doesn't have to be in our integrand. So that's a pretty good simplification here. Let's integrate. Okay, the antiderivative of 1 in terms of theta is just theta minus, now the antiderivative of cosine 4 theta is sine 4 theta multiplied by 1/4. Now this 1/4, if you don't remember, that comes from the u substitution that we didn't actually show, but we needed to do in order to integrate. Do a little bit of rearranging. And this is our antiderivative. Now we just need to substitute. Our first bracket gets a pi halves. And then our second bracket gets a 0. Okay, sine of 2 pi is 0. And then, of course, sine of 0 is also 0. We'll simplify out those zeros. And this gets us to our final answer, which is 49 pi over 8. Great. So that is the area of a one leaf of a four-leaved rose curve. Let's check out number 7 now. Now we got to find the area of the region shared by the circle r equals 0 and the cardioid 3, 1 plus sine theta. So in true AP fashion, we're going to go ahead and graph this. On an AP test, this would usually be given to you, so I'm not too concerned about that. Let's take a look at our shaded region, or what should be shaded. It's shared by both of these curves. So inside both of these curves, where is that region? Well, definitely it includes this semicircle above the x-axis. So we actually don't need calculus for the area of this yellow region. We know what that region is. This area is half of r squared, which is half of 3 squared, which is 9 over 2. And I almost forgot pi. Okay, so half of this is pretty easy. It is 9 halves over 9 halves pi. But what about the other part of this region that is under the x-axis? And you'll have to forgive the sloppy shading job that I did here. But the blue region here is, inside the cardioid, but and also inside the circle. But as we draw radii, let's draw a few radii here. Looking at these radii, the only equation that matters is the blue equation, the equation of that cardioid. Now if I grab just one radius here and I start to sweep it around the blue curve, radius doesn't get that small over there, but you can see that how that blue curve, we are basically going from this direction, which is pi, all the way over to this direction, which is pi halves. Now we also see that if I go from if I go from pi to 3 pi over 2, that's the same as going from 3 pi over 2 all the way to 2 pi. So this is kind of symmetric, and I'll show you how that symmetry works in 1 second. So I think we have all the information we need to find our area of the shaded region. The area of the entire region is the area of the yellow section plus the area of the blue section. We know the area of the yellow section is 9 halves pi, and the area of the blue section we're going to figure out using calculus. Like every other polar curve, the area of the blue section is the integral from theta 1 to theta 2 of 1/2 r squared d theta. Now the lower bound of the area is pi, and the upper bound of the area is 2 pi. Now one mistake that I see pretty often is students will put a 0 here for the upper bound because they're used to that direction being the 0 radian direction. That's a little bit of a mistake though, because we need that upper bound to be greater than our lower bound. So the next place that we go after pi is 2 pi. So you got to kind of think of this in a sequence as much as you're thinking of this in terms of direction. The radius that we're going to use is just going to be the radius of the cardioid. Now we're going to want to simplify this a little bit. Let's start by dealing with the square. So we'll square each of those factors separately. 3 squared is 9, and then 1/2 times 9, that's 9 halves. Next we'll expand 1 plus sine theta squared. That expands to 1 plus 2 sine theta plus sine squared theta. Then we'll work on that sine squared theta using the power reducing formula. We have sine squared u is 1/2 1 minus cosine to 2u, and the angle that's inside of our sine squared is theta. So we'll change all of those u's to theta. And then that's good enough for our substitution. Let's distribute that 1/2 now. And then we can collect like terms. And I think we're pretty much done here with factoring things out. So let's get started with our antiderivative now. Actually, I almost forgot. We were going to use symmetry here. So instead of finding the integral from pi to pi halves, pi to 2 pi, we're going to find the integral from pi to 3 pi over 2, and then just double our result. So the antiderivative of 3 over 2, that's 3 over 2 theta. The antiderivative of 2 sine theta, that's negative 2 cosine theta. We'll keep the 1/2. And then the antiderivative of cosine 2 theta is sine 2 theta multiplied by 1/2 from the chain rule, or the u substitution, which we'll just multiply with a 1/2. And then a little simplification here. And we have ourselves an antiderivative. All right, let's substitute. First, we substitute 3 pi over 2. And then we substitute pi. Let's evaluate our trig functions next. Cosine of 3 pi over 2 is 0. 2 multiplied by 3 pi over 2 is just 3 pi. And then sine of 3 pi is just 0. Cosine of pi is negative 1. And finally, sine of 2 pi is just 0. Okay, let's get rid of all of these zeros. And then we'll do the last little bit of multiplication here. And then finally, we'll combine like terms. Well, okay, that's actually the hardest part of our problem. Did you forget that this was just part of the problem? Because now we've got to take that 27 pi over 4, and that's our area of the blue section. So our total area is 9 pi over 2 plus the area of the blue section. The area of the blue section is 27 pi over 4. We'll start combining terms together. So we've got 9 pi over 2, which is 18 pi over 4, which is 45 pi over 4 plus 18. Okay, so that is our question number 7, and we've done 2 really difficult problems so far. Maybe we can catch a break for the next one. It's find the length of the curve x equals 7 sine t, y equals 7 cosine t, and we're going from 0 to pi over 4. Let's remember what the arc length formula looks like. Let's zoom in a little bit here. We've got that the arc length equals the integral from t1 to t2 of dx dt squared plus dy dt squared. That looks better. And then we're going to have to figure out our dx dt and dy dt. If x is 7 sine t, then dx dt is 7 cosine t. And if y is 7 cosine t, then dy dt is negative 7 sine t. Now we're ready to substitute into our formula. T1 is 0. T2 is pi over 4. dx dt is 7 cosine t. And dy dt is negative 7 sine t. Okay, so this is our formula. Before we integrate, let's take a minute or so to simplify. Now we can do all the squares. 7 cosine t squared, well, that's 49 cosine squared t. And then likewise, negative 7 sine t squared. Being a little more delicate here, this is the same thing as negative 7 squared multiplied by sine of t squared, which we can simplify to 49 sine squared t. Now the other thing we can do is now we see that both of these terms have a 49, so we can factor that. And then we could use properties of square roots to separate out the two factors. Square root of 49 is just 7. And you might recognize cosine squared t plus sine squared t. That's just 1. And then the square root of 1 is just 1. So the antiderivative of 7 dt, that's just 7t from 0 to pi over 4, which is just 7 pi over 4. So that takes care of our question 9. And let's get one more down, number 10 here. Particle moves in a plane with position vector rt given by 5t plus 6 e to the negative 7t. Let's find the velocity vector at t equals 3. Well, that's not that bad. Let's figure this one out. The velocity vector, v of t, that's just equal to dx dt, dy dt. And that's just the derivative of 5t plus 6, and then the derivative of negative e to the 7t. The derivative of 5t plus 6, that's just 5. And then the derivative of negative e to the 7t, that's negative 7e to the 7t. Now if we want to find the velocity vector at t equals 3, we'll just substitute 3. And that does it. 5 and negative 7 e to the 21. This completes everything that we were planning on doing here on the second part of our Chapter 11 practice test. We'll see you for the next one. Have a good one.